Is 26, basically, this is 1.3. 26 says, determine how much time is required for an investment to double your money if the interest earned is compounded monthly. So here, the interest rate is equal to 6.25%, or yeah, 25%. Now remember, for the rates, we're going to convert those into decimals, all right? And they want us to double our money. And one thing that they mention is that it is compounded monthly. Okay? And so to set that up, yeah, to reread the question, it says, they don't give us how much money we start off with, but they're saying whatever your initial investment is, you put it in the bank, they pay you 6.25% interest. How long would it take if they compound the interest monthly to double your money? All right, so this is not that hard. All these problems are going to have the initial amount, A sub naught, times 1 plus the rate, and we'll do something fancy here. But this is the cycles, and then your final amount A. All right. So now here, because it's compounded monthly, how many times a month is, or how many times a year is that? See, they give us an annual percentage rate, but then they say it's compounded monthly. So here's the weird thing. It's n is the number of times it's compounded, so it's n's always going to equal 12. So we take this variation of the formula and we change it a little bit and say A naught plus R over N raised to the N times T, because normally there's just a T in here. So that's the only variation, all right? And so since N equals 12, so I almost have everything I need. Here's the problem. What do I start off with? Do we know? No. So I could just say that this is A times 1 plus the rate, which is 0.0625, all over 12, raised to the 12 times T is equal to, now whatever I start off with is A, so what will I end up with? Double A, or 2 times A, so I'll say 2A. Well, we're not quite done yet. Algebraically, I can divide this and this, both sides, by A. Now this is a pretty common practice. You'll see a lot of, like, if I were to say triple your money, what would be different? This would be 3A, right? So that's the only difference. You can plug in a number too, if you wanted to. But anyway, so this is going to be 12T is equal to 2. Now, to solve T, you could do that algebraically by using natural log if you wanted to and bring the exponent out. Or we could just do systems of equations by graphing the left-hand side expression and graphing the right-hand side. So if I go into a calculator, for my first expression, I want all this 1 plus stuff. So I'm going to change that, and I'm going to say parentheses 1 plus another parentheses 0.0625 divided by 12. Close my parentheses. Wait a minute, I got to close a second set of parentheses, because here I have 2 opening parentheses and now I have 2 closing. If you don't do it that way, your graph will come out funny. Now what's that raised to? 12 to the T, but my calculator says X, so I'm just going to say 12X. Alright, do you guys see how I entered that in my calculator? Okay, so now what I'm going to do is I'm just going to hit graph. Uh-oh. Where's my graph? Now, if you don't see what I see, it's because your zoom is not set to what mine is set at. So if you click on window, I know that my X value isn't going to be bigger than 20 because I did problem number 25 and it was approximately around 11.43. So my X value should be from 0 to 20, right? I shouldn't have any negative years. right? Because x represents the number of years. And then my y scale, I'm solving for y equals 2, so my y value shouldn't be higher than 2. So I set my y scale from 0 to 3. So now that I see the two lines, this line here represents the exponential growth, and the horizontal line represents the y equals 2. So now I can hit second calc. Whoops, let me jump in there. If I hit second calc, I can choose option number 5. And option number 5 will let me figure out the intersection of those two lines. So first curve, I got to make sure that the curve is somewhere near my answer, and I can't even see it on the screen, can I? Alright, well, where the heck is it? Well, my x value is pretty darn close to 0, right? So I'm just going to keep lowering this until I get to like x equals, oh, there it is. See what I did? And I want to get as close as I can to the intersection. Hit enter. Now my second curve should be about the same spot. And then I'm going to hit guess. Now this is saying 1.87. Does that seem reasonable to you guys? Our last problem said we could do it in 11 years. This problem says that we could do it in 1.87 years. What's up with that? It's monthly, but should it be that far off? So I know it's hard for you guys to imagine, but maybe Mr. Adams made a mistake. So let's double check. Probably I entered it in the calculator wrong. We'll see. So 1 plus the quantity 0.625 all over 12.
0.0625.
Yeah, I put it in there though. I'm thinking that maybe, just maybe, I should put this 12x in parentheses. Let's try it and see. So if I hit comma 12x, let's see if I get a different graph. Uh-oh. Completely different graph, right? Now it looks more like an exponential. So, my bad. Mr. Adams made a mistake there. So now let's do it again. So now we're going to hit second calc. Now I did that as an honest to goodness mistake. But it's good. I wanted to show you, because you'll probably make those same mistakes as well. So when I got my answer, I did kind of a common sense check, and I said, well, that doesn't seem right. So I went and double checked my work. So now I'm doing the whole intersection thing again, and now I get a much more reasonable answer. It seems like x equals 11.1, but what does that mean in English? What does the 11.1 represent? The years, right? So we would say that it'd be t is equal to 11.1 years. Okay, so what does that mean? That means that if I put a certain amount of money in the bank at this interest rate that compounds monthly, I should expect to double my money in about 11.1 years. Okay, any questions on that one?